Good morning. How are you doing, young men and Roy? Well, I can't hear you. Let me see if I've got my.
Good
Uh,
morning, Drew and Roy.
Hey, I can.
Hi,
Nope.
Tony.
That's
Hi, Roy and Drew.
it's good to chat with you too. How are you all doing?
Early in the morning.
I'm still waking up. I usually get up early to fly, but today I was just dragging. I stay at home for this meeting now, because I would have to get up too early. Hey, Mita.
Morning. Morning, everyone.
Good morning. Give people a minute to join. Um, I think we're pretty close um to being ready to call the spec releasable, but I want to, hopefully we can talk about that today. And then we've been going through a memory scenario and um, the hardware fault management meeting, and uh, so this will warm both of your hearts, hopefully, as I'm trying to explain. Hey, you know, you could have a memory fault, and if you write a zero to a cell that's stuck at zero, you get no errors. And if the OS doesn't access that memory, you only get an error once a day when the patrol scrubber hits it. And I'm just trying to explain why we need to analyze these errors, and also the reason we don't want to count them. And we're trying to write these scenarios in ways that they're kind of tutorials, not tutorials, but they're just explanations that anyone that's interested can read. And so, what I'd like to do is, I think both of you have told me, hey, you're replacing too many DIMMs at different times, or this isn't the right way to do it. And so we're trying to advertise that. So I want to mention that, and then show you how we're tracking those scenarios, and then based on how we track those scenarios, I think we can pull them out of the. We don't need to put them in the memory fault management memory doc, and we'll just reference them, and that way we can release our doc and then do the scenarios independently. So just it's a way to move things forward, but it's also a way to explain things that you all as memory vendors have been saying to me for years and years and years, but explain them to other people in a way that it's a group of industry experts, explain helping people do the right thing with memory. So while we wait for people to join, I'll show you what I'm talking about. Give me 1 second.
And I put it on my list, Drew, to kind of go through those memory scenarios you were talking about on Friday.
Awesome. Yeah,
and I didn't speak up on Friday, but everything you guys said, I think landed on something I agreed with. So
oh, good. That's me.
You can take my silence as agreement.
Okay.
Everything that Charlie spoke up with, and I don't know who all else pitched in, but I think we landed on the correct stuff, in my opinion.
Good. Thank you. Yeah, and I'll share the screen, and so yeah, because the FMFM document has one of these scenarios in it, and I realized I wanted to cover it in the main document, and also, Anil was saying, hey, we need to get the this document out. Do we have time to review a bunch of scenarios? And I agreed with him that we should pull them out. So I've got it in work in progress for now, and we may need to just make a scenarios directory as different, because I think Mita pointed out on Friday that hey, how do we track which ones are done? And so I've got 3 documents in here. One is a table of contents. It's just all the scenarios. Maybe I should call it scenario list. I'm gonna change that real quick. And so this is a list of scenarios, kind of like a table of contents with links. This is a a blank document for people to fill out. And then I did one for memory corrected errors and some common things. And so what it looks like is, we'll have lists here. And can you see what I'm sharing okay?
Yep, looks good.
And so, we'll have a poison recovery one, or I'm doing an analysis of memory errors at runtime leading to a PPR. And actually, I don't know if it's soft PPR or not. It could be either, really. But you can just see we can put different scenarios in, and like if we want to do a poison containment for PCIe, we can have it in both places. So it'll just be a table of contents, and this is just so people can find the documents. And I just made a blank document, and then I made an example document. And if someone wants to help me write more of this, feel free. And I'll put I'm going to start by putting the link in to the folder so that you can see everything. Let me just chat that link. Okay. And so then I have an overview of the scenario, and I really am pushing rate limiting, and you'll see why as I walk through it. And I've added things. I've added assumptions. I've added some goals of the analysis. And I'm also talking about some common misperceptions that I've seen. So I've added that since we last talked, like the ability to diagnose memory from a single corrected error. People, no one serious imagines that, but some people like, you got the error, just analyze, just look at the error and tell us what it means. And I'm arguing that we need to look at multiple corrected errors to figure out the scope of the damage or the scope of the fault. And then, we don't want to count errors. We don't need to capture every error. And so, Roy, if you want to reinforce the need to capture every error, that would be awesome.
Oh, yeah. Okay. I will add.
Because you've got data, right, that you shared here. So if you're willing to share any part of that, it would be wonderful to have you all chime in as memory vendors. But then
Okay.
I walk through the scenario, and I say, okay, there's a part of a row that fails, but it's not allocated to software. But it was all initialized to 0, and I just kind of say, look, we don't see anything. There's no error, and then someone writes a 1 to one of the failed partial row that was stuck at 0. And now we get a single bit error, but it's corrected inside the DRAM. We see nothing except for the ECS mode registers. And then software writes a second bit to the same cache line, and now it's in the same DRAM. And so we start seeing errors. And then we start reading the error infrequently. So we see few errors, then we read it frequently, and we handle the storm. And then we write another cache line in another place. So now we see error rows in multiple places, and now we can decide that it's a post-package repair. But what I'm trying to emphasize is that we're looking at memory errors, we are subject to whatever the software is doing. So if it writes a value to memory that matches how the memory is failing, and the memory is failing consistently, then we might see anything. We might not see anything. And if the OS doesn't ever access the error, then we might only see it once 24 hours. And then if they start accessing the same piece of memory really quickly, we can get a storm of errors. The fault didn't change in this entire scenario, but what we saw was radically different based on the changes in software behavior. And so my argument is that we need to monitor memory over time and look for a pattern and figure out what's going on. And that with chip kill ECC, that's okay because we'll stay up. And if you all want to debate this and work it out with me, I'm happy to. I didn't mean to go over it in detail yet here, but I just wanted to show you. I'm trying to do something that I think represents a mutual interest. Right? I'd like to see smarter memory analysis algorithms. And I think you all would too, right? You don't want people, replacing memory for stuckouts or, assuming that because you had a burst of radiation strike, a small burst of radiation strikes, that DIM is bad. So anyway, please, take a look. I welcome your feedback, and I'll paste this link in too. But my point is, for the moment, and I'd like to walk through it actually in great detail with you all. But my point for the moment is just that I'd like to pull these out of our FMFM doc. And so if you look at the FMFM doc, I'm now scrolling through that. Okay. We have the airflow examples, and I'm thinking maybe what we could do is put a link to the example and say I've copied the example in here. It's shorter, but now that I've pulled it out in a separate document, I can elaborate on it. And what I'd like to do is take all of these examples, put them in the table of contents, and then fill out a sub-document for each of them, working with you to make sure that it, we agree that this is how it ought to work. So does that make sense to you all? Is that okay if we pull these flows out and reference them somewhere else?
Yeah, I think that makes the most sense, Drew.
Okay, and I'm not trying to do anything controversial. I just, I want to get the spec out quickly so that people can start implementing it, gathering the data that we've requested. And I don't want to hold it up, for us walking through the flow. So what we'll do is we'll walk through those flows in separate documents. And then as we agree on the flows, we'll mark it as no longer a work in progress, that this has been reviewed. And, we'll put all of our, if it would help if you all want to put all of your names on it as authors, to say that, it's industry experts, and I want Vilas and Yogesh and others at, Intel and AMD to put their name on it and say, hey, look, all the experts got together, and here's what you need to know about memory errors, and for this scenario. So if that's okay with you, I'll pull that out of this doc and then put a link to the other doc, the table of contents, and then the table of contents doc will have links to the actual scenario documents.
Yeah, do it, bro. That's good.
Cool. Oh, thanks, you guys. I didn't see that you were here. That's awesome. And like I said, I would encourage you all to add your names to it, and add your content. Like help me make it represent something that we agree on, so that I can go to, like when we saw last time we saw a row hammer problem at Google. Some really smart kernel people were like, oh, we'll just count memory errors, and we see a lot of memory errors. We'll assume we're being row hammered. And I'm like, no, please don't do that. And I was able to explain to them why that was a really, really, really bad idea, and that it probably wasn't row hammer, and that you'd have almost all false positives. But having some documents that I point to that can explain memory errors would be amazing, because then I don't have to make the explanation. I can point to this and say it's been reviewed by the experts. We've agreed to it, and if you disagree with it, I'm happy to explain it. But you're also disagreeing with a bunch of us. So anyway, I'd like to get feedback from the memory folks. Are we okay with what I'm proposing?
Sounds good to me.
Thanks, Charlie. And Roy and John Min, are you okay with what I'm proposing here?
Yeah,
Yeah, I'm good. Yeah.
good.
Okay. And like I said, I strongly welcome folks jumping in and putting questions or helping me clarify this scenario. and you know, if you have other data, like I know Roy's done some analysis of uh, you know, we don't need to capture every error. So anything we can put in there would be great, and then we'll have kind of a unified view of and I'm not saying this is how you analyze errors. I'm just saying what I'm trying to say is don't make these mistakes. Don't make these assumptions. Please understand. Uh, and if you all want to add a bullet somewhere that says, you know, the memory vendors have technology that they're each, you know, applying here or something, that's fine. You know, we're certainly not trying to limit you in any way. We're just trying to correct misperceptions. So if you have, you know, and you don't want to say what the technology is, you can just say the memory vendors may innovate here, and you know, that's good enough. So, okay, cool. Well, thanks. So then we can go back to our regularly scheduled review of the doc. I think we're pretty far along. I mean, this is looking pretty good. Let's go back to those grids once we think about them a little more. Okay. So I'm just going to the first comment. I think one of our recent reviews, well, you had an action item, Evan. So why don't we take a quick look at it?
Yeah, Drew. I wrote something in here quick. The point I'm trying to get across is that like the reason we put the DFA log output kind of separate is to have that as an option. To not necessarily the thing I want to avoid is putting it necessarily behind the system fault analyzer. I don't necessarily want to have that as a gate. Like I know we need some input from the system fault analyzer to do the DRAM decode and that kind of thing anyway. But what
Well,
I'm
and
trying
to assess the error in light of the ECC, right? I mean, on one chip, the
right,
ECC may handle it, on another chip, it may not. But I see your point that you want to expose what you're thinking.
right, yeah, and that's at least want that option. And it, you know, it's up to whatever policy for whatever server operator how they want to weigh that versus the SFA output. Maybe they just take the SFA output and that's okay. But I think in the cases like we get asked a lot for what our opinion is, and I'd just like to
Yeah.
be able to directly have that option.
So here's what I would propose is what I was thinking is that, you know, we want one piece of code that we send the seepers to.
Yep.
And then it decodes it, it calls your analyzer. And then I think what we could state is that when there are two things that come out of the analyzer, there's, you know, JSON decoded data that just explains what's going on. And you know, and we can look at registers and then there's the CPAD, which is geared towards automation. And so what I would think is if you have a decoding or an interpretation of your section, then maybe what we should do is say we send the seepers to this analyzer. The SFA will decode it, pass it to the DFA inside it, and then the DFA will provide proprietary information to the SFA and based on decoded section to the SFA, and that the JSON decoded section should be included in the SFA's decoding of the error. So,
Okay, yeah,
is that okay?
yeah, that sounds okay to me. Yeah, we just kind of specify that is the output.
And just as an end user, that makes it easy because then
Yep.
what happens is whenever I do analysis, I get two things. I get the decoded JSON and I get the CPAD if there is one. And what we can do is just ensure that your stuff is included in the decoded error. And you know, you have a place. Well, I think what you do is you just provide text to the SFA, and it includes it as a section of its output. And then as an end user, I just have to grab the decoded data and the CPADs and act on them as I need to. And I can store the decoded data, and then if I have questions about a DIM, that's doing something funny, I can call you and I can show you all the decoded outputs that I'm capturing anyway, and you'll have it. Right? We don't have to do anything special.
Yeah, I guess the thing I'm thinking of, Drew, is as long as we're strict that the data doesn't get interpreted in any way
Okay.
in that output. I think as long as we're clear on that, that's fine with me. And the scenarios I'm kind of thinking about in my head are things like something we have written here is the DRAM fault analyzer suggesting that it's a system issue, which is more of a we can't tie this to a DRAM issue we know about. And like in cases like that, we want to know what the system fault analyzer thinks of it. But in cases where we know exactly what the DRAM error is, we don't ever want that to get kind of overridden by the system fault analyzer and whatever it might think of that error.
Okay.
So and that confidence level is kind of at the bottom of this section too. So, there's going to be a number of those that are very high confidence DRAM faults that we know what's going on, and then a number that are going to be, anything we suggest a system is going to be a very low confidence number.
Got
So
it.
I think that kind of helps tie that together too.
I'll put a picture in showing how I think that works, and we can, it will just take me a little while and propose that. So I'll make sure that's really clear. And Yogesh, is that okay with you, Yogesh? Or you tracking?
I'm thinking how we actually plan to achieve that systemically in Rust API framework. I think our ID structure should drive us here to where to. Now I know that we don't have an ID for like a DFA level analyzer, but I think we need to do some work in that and bring those concepts in here.
But I can show you what. Okay, so if we go to the picture. Okay. It doesn't change the CPADs at all out of the analyzers, but it changes the decoded text. So, and there are two things. There's the decoded data, and so I think all it is it's just a section of your decoded data.
And that decoded data is coming from SFA.
Yeah. So our expectation was that we have a JSON decoded thing, and if you have the right relationship, you might the decoding may vary, right? If it's the gas station down the street with a server in the closet, they may not have an NDA, and so they may get limited decoded output.
Well, let's just talk routing, right? Not the implementation, right? So routing wise, right?
Yeah, I mean, okay. It's probably just I can whip something out and show you what I'm thinking. So, okay, so you get a CPR in, and you have the SFA, and I'm not going to bother doing this the right way because I'm trying to go fast. I'll make a nicer drawing later. Okay, and then you have the DFA inside it, right?
Yeah.
Okay, the CPR, it goes ultimately to the DFA, and I'm glossing over the decoding, but there's the SFA decodes it and formats it in a way the DFA can get it. Let's just assume that's the case. Okay, there are two outputs of the DFA. There's the decode, or there's JSON. There's some sort of JSON description, and there might be a CPAD. Okay, and so those come out. Now the SFA will also have some JSON, and you know, I'm making it bigger because I'm assuming, you know, it may have more, and it also has a CPAD. And then the output of the SFA would be a CPAD and a JSON. And actually, I don't know if this is a CPAD or if this is a CPAD driver. You know, there's some sort of communication, a CPAD like suggestion. You know, because the problem is that you can't really write a CPAD from the DFA because like if you were to say do a post package repair, the SFA has to figure out which registers to write and what the data, you know, like format the data in a way that it needs for its chip. So, you know, I think what there's some sort of work here that goes from a CPAD suggestion from the DFA to the actual CFA that works on the memory controller. Are you all following me so far?
Yeah, no, I understand the hierarchy, Drew. What I was trying to get at really is which IDs. We don't have any IDs described yet.
Well, but I guess
From the CPER world, which record ID, header dot record ID, which you know, header dot creator ID, platform ID, and
well, I mean, all of that is particular to the memory controller, not the DIMM. So that's all just part of the CPAD. We're really talking about decoded uh, uh, output here. That's it. So you have the SFA.
so yeah, okay. So SFA context itself,
So,
we need to have the
so
IDs. Right?
this would be the output, right? Like that's all we're talking about.
No, I understand that. That's fair. What I'm saying is we have not included IDs in any of our descriptions yet. Have we?
Mm-hmm. And
to align with RAS API, that's the exercise we need to add before we release this document.
oh yeah. Well, actually, but I would put it this way, Yogesh. Okay, what do we use the IDs for? We use them to make a round trip, right? So we have CPER, we capture, we analyze it, we send a CPAD back. That CPAD is not going back to the DIMM, it's going back to the memory controller. And then the memory controller needs to know which DIMM, but that's a memory controller specific thing. So that's a chip specific thing because different chips might have different numbers of memory controllers and different numbers of DIMMs on the channel, but that's something that you capture in your CPER and the analyzer will know about because it knows about your memory controller. It knows about your SOC. You made the SOC. And so my point is that the CPADs go back to the SOC, not to the DIMM. And I don't need an identifier for
Understand. I now understand that. It's just that we don't have anything in terms of IDs this included yet.
Yeah. Well, so for the purpose of what we're, and I'll clean this up. Oh, that's really weird. That's a new one for me. I've never seen the Google Drawings do it. I'll work on this. But okay. Well, so let's just take one thing at a time then. For the purpose. So iPhone Meta 2, you got feedback.
So let's do this, Drew. Let's table this ID discussion for now. I'll work on this some too and bring it for next time and put it for review.
Okay.
Let's try to get through the rest of this document today. I think we are very close.
Sure. No, but I guess my point is that Evan is saying that, hey, the memory folks would like to be able to include some output that we can look at that describes what the memory vendor thinks about a memory problem. And so I'm proposing.
I think I would call it either debug hint or you know, action hint from SFA to DFA, and DFA creates the final CPAD.
Yeah. Okay. So I'll call it action suggestion. How about that? Is that okay?
It's fine, but if you want to say a few words, you can also say hint.
Yeah, I'll
Yeah, either is fine.
okay. I'll work on it. I mean, we'll describe what that is, but the thing that Evan was talking about is this JSON that they want a place to put something out that says, here's what we thought that we can see as end users. So are you okay with them giving you some JSON from their interpretation of the memory problem that you just embed in your decoded output?
Embed as in without making any changes to it. You
Yeah,
want it to be passed through.
yeah, just pass through. Just
SFA pass through as it is, and on top of that, another JSON which is DFA, or actually SFA, DFA pass through. So your naming in the bottom box is actually wrong. It seems like SFA is a smaller JSON, but it seems like your DFA JSON will be the big action one, and the
oh gosh, you're right. Hey,
backwards. DFA will be just a small pass-through hint thing
yeah, yes,
for
you're
analytics at the infrastructure level, but DFA, SFA JSON is the one that would be decoded and would be basically driving the CPAD recommendation for the infrastructure.
yes, because
Then,
the
and
memory.
you can take a look at it and say Yogesh doesn't know anything. I'm just going to listen to Ivan, right?
Well, but I mean that's not the intent. But it's just that hey, if I need to if it's a weird thing with a micron dim, then I can capture all of these DFA JSONs and send them to Micron or talk to Micron about it and go, hey, what's going on? And we can have a conversation about the Micron part um, that we have questions about. So it kind of makes sense to me that the memory vendors want to be able to pass through some information about what they think in the decoded data.
Yeah, and that'll certainly help us when we get questions, Drew, just to know that like that's actually what, like to just be 100% certain that that's what our analyzer said.
Yeah, I think is okay. Vilas is not here, and neither is Dean. I think we need to also discuss this with others, but I'm in principle not against it. I don't want to block any debug information at any level, but there may be some nuance there in how different silicon vendors may think about how to handle it. You know,
And yeah, and in terms of ARM, it's really not up to ARM itself. It's up to the ecosystem partners, right, as to what they want to expose. So it's more like, if Ampere, I guess if ARM makes
I wouldn't put it like that. I think, yeah, it's a mutual decision. And Sab is here. Sab, what any thoughts on what we're discussing here? I guess not. Sab is from Ampere, I believe, but that's all right. Sab, if you're talking, you're on mute. And then we also have Anil, I guess, back to his office in Sean. So I think, yeah, we have good.
Okay, I'll clean this up and we can run it by, like I think the vertically integrated CPU vendors have a stronger stake in this. And in terms of, I can see it's a little bit even more complicated with ARM because this decoded SFA JSON is not a monolithic thing. I might have a block from ARM, I might have a block from Cadence, and another block from Synopsys, depending on whose IP I've constructed an SoC from. So, it's just a little bit, it's a little different, and I can work that angle separately from this doc. I'll worry about that.
Yeah, and that's the layering complexity that I am talking about. Vendors may want to handle it differently, especially for different customer bases. It's a CSP infrastructure is fine. If it's a mom and pop store, every little thing is a RMA, right? So
Yeah, yeah, and your decoded words may be a lot more terse, and that's my point is that what's decoded and exposed to the end user can vary based on the relationship you have with the end user. You can have an analyzer you just release, that you release widely, that if consumers ever have ECC in their system, they could be an analyzer that even they could use that would give them a very terse message about what's going
Yeah.
on. And then
Yeah.
with us, with hyperscalers, we tend to want to be partners in helping you get the best possible products out. It's because we want good products from you, and we're willing to share data. And because of that partnership, we hope to get more detailed data.
Yeah.
So,
Hey, Charlie
well,
and Beta, yeah, sorry, Drew, didn't mean to interrupt you. Just
okay.
just
I'll clean.
Charlie and
I'll-
they might want to chime in. Charlie, what do you think? You have a lot of experience.
Good question. No, I tend to agree with Drew. Cisco would like to partner with our vendors to improve product, right? So it's just a question of how we share information, as much information as possible, and not have people who think they know RAS jump to conclusions. So, whatever we engineer here, it has to be geared towards sharing the right information and not generating misinformation.
Yeah, I'm along with you there, Charlie.
And I can add that I think that the hardest part about a lot of things in RAS is deciding on the right heuristics. And getting those heuristics right usually means you need to observe tons of data. And even if like RAS API gets us the observability as a first step and the heuristics come after that, that makes sense to me. So this is in line with that.
Yeah,
Awesome.
and Drew, by the way, I just sent you an email, regarding page retire in Linux. I just had a conversation with some of our Cisco engineers yesterday, kind of going through what threshold should we have for correctable errors. And if I had a dime for every time I've had this conversation,
Yes, yeah.
I wouldn't be here today.
And wouldn't it be wonderful if the memory vendors and the CPU vendors gave us guidance on where we were at risk? Yeah.
Yes, absolutely. Because what I see happening is a lot of the hardware engineering teams make their own RAS decisions, and they have a horrendous amount of misconceptions.
Yes.
And then only when the what hits the fan, and I get called in, it's like, wow, where did you guys? What were you thinking when you came up with all of this stuff? Who were you talking to?
Yeah.
If I may add something here, that some of these decisions, they are not just hardware dependent, not just software dependent. We have to think through the whole system as a single entity to figure these thresholds out.
Yeah, it's a system level decision, right?
Yes, yeah, right.
And that's the kind of vision we bring from a RAS point of view, a system view.
Well, I think that's valid, but we need to do it in light of like a true understanding of the problem. And I think, even at HP, I would do the same thing that Charlie did. I'd come into a group, would talk to a group that I hadn't worked with before and see what they were doing and be horrified. Because they didn't understand memory errors very well. So I think we just want to spread that knowledge, but I agree that it is a system level thing. And so we'll probably, that's why, in the analyzer framework, we need things from the BMC as well, because, my classic example is you might have a flaky PCIe link. The CPU may blame a GPU, the GPU may blame a CPU, and the BMC may say, oh yeah, I had a bunch of clock glitches. I've got a failing clock circuit on this PCIe link. I'm the problem. And so we do have to look at the system level because, voltages, clocks, there can be all sorts of main board problems that contribute to memory errors as well. Cool. Okay, so hopefully we're aligned on this. I'll clean this drawing up, but I'm just trying to reflect what Evan was saying, and and Evan, I think what you said made sense, and I hope that the way I drew it here made sense to you.
Yeah, that
It,
makes sense to me, Drew. I mean, I understand there's a lot of discussion to be had about kind of what this means for the implementation, but I think the gist of what I was talking about is definitely here.
Cool.
hey, Drew, sorry, I joined a bit late. Can you just summarize what is changed? What you're changing here? Or what is
No,
the
nothing big. It's just that the memory vendors will have uh, some work they do on the memory. They'll have some sort of conclusion, and they want a way to include that conclusion in the decoded output. So the memory analyzer will have a suggested action to the CPU vendor, but the CPU vendor has to make the CPAD because it's targeting their memory controller. But they could also have some JSON that we included in the decoded SFA JSON. So like an Intel analyzer might have Intel decoded error, but then embedded in that, we want just a place where the memory vendors can pass things through. So if Samsung or Micron or Hynix say, hey, I think this about my memory, then it's in the decoded data. And what we do is if we have a question for one of the memory vendors, we can show them all, what their analyzer inside the system fault analyzer said. So that's all. It's not really a big change at all. In fact, it's trying to keep it consistent so that CPERs come out, decoded data and CPADs. I mean, sorry, CPERs go in and the decoded data and CPADs come out. But there's just one decoded data that includes both the Intel and the memory vendor data. And this
I
is just
see.
production. So that's all.
Okay. And that CPAD then fits into the bigger block diagram where it goes back to either platform or, I mean, it goes back to platform and it goes into infrastructure for further
I
remediation.
mean, it is the CPAD is what we automate with typically, right?
Yeah.
I'm using the M-band version of the drawing even, but yeah, the CPAD is what we automate. But then the decoded stuff we can store, and we can do. If I want to look for new signals, I can look through the decoded data and apply AI to it, or but this is completely consistent with what we've been talking about.
All right. Thank you.
And the gist of it is the analyzer should have two things. One, some details about what's going on. Those details will vary depending on their relationship with the end user, and then a CPAD, which we can use to drive automation in the data center. Cool. Okay, Evan, I'm going to accept your changes, um, and then I'll clean up later.
Yeah, sounds great. Thanks, Drew.
Okay. And so here's where we stopped last time. I'm going to clear that and get rid of the highlight. Okay. And then a long, long time ago, we asked Roy to fill out some scenarios. And and Anil, earlier I proposed that we pull these scenarios out and link to the document just as you and I've been working out. So we're not getting rid of them. And by the way, I fleshed out a lot more detail in the corrected error scenario. But my thinking is we're just going to do what you and I talked about, right? We'll have a list of scenarios, we have a template, and then we'll have
Drew, are you sharing?
I'm
Yeah, I
flipping
can
between.
see it, Charlie.
Oh, that's interesting. So this in Zoom, how do I? Okay, never mind. I've done something and I'm just seeing I'm just seeing you, Drew, and not what you're sharing. So
Oh, I'm sorry.
never never
That's
mind.
not what you want to see. Okay.
You should not be sorry, Drew. I mean, it's always to see you in the morning.
Yeah.
It implies.
So anyway, Anil, I talked to the team earlier about pulling this section out and then referencing it in a sub-document. So, and that didn't seem controversial. So that's my intent is I'll pull this out and I'll make sure the kind of table of contents document lists all these scenarios. And then we can just spin off those documents and walk through them and review them separately once we've got the spec out. So then I think then we're pretty much, we need to fill out these empty sections. And I think one of the things that we want to do is walk through through scenarios. And I'm imagining we delete this section of the document or clean it up. But this is just what's next. So I don't know what else we need to do. I mean, I guess we need to handle the orphan content and clean things up. But we're really close. So I will. Oh, Anil, are you gonna be able to do this, or do you want me to come clean up these addresses? You're on mute, by the way.
Oh, sorry. I didn't know that I had to fill this up. Sorry. Let me check. Let me do it.
Okay, no biggie. I mean, I don't care. I mean, I'm not being flippant. I'm happy to do it, or you can do it, whatever. Yeah, and then we need to address that.
Did we use OS physical address somewhere in this document?
Yeah. Yeah, we did. And though it's important to define that, because if you look at JEDEC, their physical address is where on the silicon is it physically. But if you say OS physical address, then that means not an OS virtual address. So that's why I think it's important to define what the OS physical address is.
Okay. Let me take it, because from an OS point of view, right, the physical address is, from a hardware point of view, we call it system address. Right?
I think though
cache
that
line address.
look at what Linux calls it, it's OS physical. I mean,
Correct. No, that's what. So just want to. I think the context we want to clarify here is from a Linux point of view or OS point of view, the address defined we call physical address, which maps to at the system level, at the hardware level, is a system address.
Yeah.
And that system address is visible or decodable by memory controller, which in turn translated into the DRAM level, DRAM physical address you can call.
Right, it's a function of memory interleaving and all of that.
Yeah.
This is what the OS sees after all the memory interleaving stuff. Yeah.
Right. Okay.
Okay, and so we can clean up the glossary. That's great. Yeah, that'd be great if you could take that, and then references. It looks okay, and we can add more if we need to. In fact, I'll add I'll add a few references like the scenarios doc. Let's see. Okay, so what do we want to do with the SPD logging stuff? Does someone want to take a look at that and decide what to do? I thought we had some stuff up above for it, but can someone take a look and own that?
So do you want to keep this here, or would it be also one of the flows? I think this should also be one of your flows document.
Well, this isn't really a flow. This is just what's in the SPD.
I think
Oh,
this
the
is a
content of the
proposal
SPD.
rather
Oh,
than, it's a proposal.
okay.
It's not what's in the SPD right now.
No, it's not really a flow. It's supposed to be, it's like an example, but it's really not a logging example. It's just SPD. Okay, logging data example, I guess. So
We need to.
I think happened on that. That reminds me. For the SPD, we had a question from JEDEC folks like, hey, how do you want to size the SPD for DDR6? We did not
We need to work on that. Can I
Right.
make a proposal, Yogesh?
Go
My
ahead.
proposal would be that we get what we want to log out as quickly so that then when we have the published spec, people can start working on it, and then we jump. Well, maybe we save this and then we come back to it and we work through the SPD as one of our next topics. So like a post 1.0 version of the spec. You know, this can be a 1.1 item.
Yeah, I
Well,
think,
like
yeah.
do it next. Is that okay? I mean, that's my proposal. But if that's controversial, we can.
No, I think we don't have to get this document by that, but I think Ivan and Roy and John Min and others, we need to start thinking about that and maybe try to respond to JEDEC folks.
Good, yeah.
I'm wondering in the in the JEDEC spec, or actually what I'm wondering here is, what does this document add to my knowledge and understanding that I couldn't just get by going to read the JEDEC spec?
Well, we're actually proposing that we're going to add things to it. So, like we might if we have analysis results, I could see sending a CPAD back to the DIM or CPAD back to the memory controller, and the memory controller, you know, we want to update the SPD with some data so that when the DIM is returned to the memory vendors, they have some data about the error or their analyzer. So do we want to record? How do we want to use the SPD in our flows? Is kind of
Okay, got it.
what do we
Yeah,
want for?
right.
And that's new. That's because we got a new flow. We just have to figure out how does SPD play into that. And I don't have a strong opinion other than I think we need to we need to talk about it. All right.
Yeah, in that case, really, that is more of a flow discussion, right? Or a scenario.
Well, but the scenarios aren't trying to define the spec for us. They're just showing how the spec is used, where we may want to define something new for how do you see what I'm saying? Like one is just correcting misperceptions and educating people and lifting everyone up so that we're all on the same page. But if we may have specific things that we want to accomplish, you know, using the SPD, and if there are, then that's a spec thing, not a flow thing. Do you see what I'm saying? Like
yeah. But that's kind of, we should be taking that discussion to JEDEC and getting them to agree before we start saying, unless we're using free space in the SPD that JEDEC has said, hey, this space the user can use. It's up to you.
Well, I would nuance that a little bit. I think what we want to do is figure out, like, how does SPD play into the flows we're creating? Do we need to update something about the way SPD is used? And then, does that change to the way SPD is used require a JEDEC spec change? And then
Yes.
that's kind of what JEDEC's asking is, hey, do we need more space? So if we have a discussion on how we want to use the SPD space, we may go to JEDEC and say, hey, we've got this infrastructure. We're doing this thing that's going to make memory more diagnosable. We want to put something new in, or we want to do something new with the SPD. We need more room, or we need you to reserve space, or whatever. But I don't know what that is yet because we haven't had the discussion about what we want to do.
Yeah, right.
Let me try to clarify something more here. So JEDEC defined the SPD format, right? And starting from DDR4, maybe in DDR3 also, I guess, there's some space in the SPD left for what they call OEM consumable, okay? Which JEDEC doesn't define, just allocate some chunk and that's it. In DDR4, there was very small space. I forgot how many bytes. And then in DDR5, they actually increased it. And there's a trend that it may increase further in DDR6. And LPD actually doesn't have a SPD yet. Now the question is, and this is persistent, right? This is EEPROM. So question is, how can it be used? Today, there are some implementations where every OEM or hyperscaler has used that space to write error information in a very proprietary way. We do that actually today, right? What we want to do here is come up with a standardized format that we can take it to JEDEC and make it part of the spec, where whether the name is written from one hyperscaler A versus B or C, the DRAM vendors can decode it
Yeah.
without any proprietary information, and vice versa, where individual all other DRAM vendors, right? They'll also see the same format data. Sorry, we will program the same format data whether the DIM actually was procured from DRAM vendor A, B, or C. It simplifies our job.
Yeah, and the other thing it does is that like in my experience, when you share failure information with the DRAM vendor, their odds of finding the problem go up dramatically. Otherwise it's a no fault found. But if we say, I think it's over, here's the data we had, here's where we think the problem might be, it really helps direct the testing and helps FA. So I'm 100% aligned with you on that, Anil. I just wasn't trying to be too prescriptive, but that I agree. That's what we ultimately want to do, and I think that we want to put that in the spec. So we want to say we're analyzing things, and then we're going to write this chunk of data into the part for later, for vendors or whatever. So
now, I would say that, Drew, sorry to interrupt you.
no.
I think in the first release of this document, we want to kind of maybe just give a hint rather than be more prescriptive, and keep this information just like a white paper we're talking about, right? Let's keep it as a separate document, because this is a longer discussion and a lot of alignment.
Agree. We don't want to hold the spec up. I guess my proposal is we don't hold the spec up for it. And I'm happy to put a hint in and say, hey, the next version of this spec, we will review how SPD plays into it, and we are going to consider writing data into it. And then we'll have some more discussions and put the details into the next version.
Or maybe I'll put another way around that we want to say that, okay, there's a requirement to make good use of the EEPROM capacity exists on the SPD to store error information for better diagnosis. And then that's about it. I mean, that's the requirement we want to capture here. The actual implementation will, sorry, not actual implementation. I think that's pretty much what we want to call out here, okay? That there's a requirement.
But for DDR5, the spec already exists, right? So what we're showing is an example of DDR4. Shouldn't the example be DDR5? And JEDEC is not asking us about DDR5. JEDEC's request is, what do we want for DDR6?
Right. So we just need to figure out what we want to do.
Yeah.
And so I think we have this requirement that Anil mentioned, that we want to store relevant information, and then we'll figure that out, and maybe we can squeeze it into some part of some of it into DDR4 in some space, and 5, and then 6 we say, hey, we want to do something more. We don't know what we want, so it's kind of hard to ask for what we want.
Right.
That's why I was kind of requesting the DIM vendors to give us some hints, hey, where we think we want to go. But anyway, good discussion today. We are almost at the end. My request to everyone is, if there is not list of contributors in the front, I'll add the table. Please add your names, and let's wrap this up. Almost on top of the hour now. So
okay, and I'm going to accept your. I guess I'll accept your change, Anil. I mean,
and one request, Anil, did Thanos leave Meta? That's why deletion, or
yeah.
Sometimes we just change like we did Carlos's, right? He just changes company name and also mentioned formally.
Oh yeah, I don't.
Yeah, that's a good point. So rather than deleting it,
because for some time he was active in this group, I remember that.
Yeah. So we should recognize his work. Yeah.
I can reach out to him and ask him his current company name.
Yeah, I think I have his
Try to do @Panos. Does it fix something?
Yeah. Let me fix that. I have his
go for it, Anil. That's perfect. If you just do it now, that'll be better. Okay, so I think for next meeting, our goal should be to go through the document, and we need to figure out, like, well, we need to pull out, like, I can make a holding document for things we want to pull out temporarily and then put back in later, like the SPD data, and then just clean up the final sections. So Yogesh, I think you're going to do one section down at the bottom, and then when we get back together, let's make a plan to say, okay, are we at 1.0, right? Like, what are the last handful of steps, and let's see if we can get it published, because I think we are that close.
Yeah, that's good. All right,
Awesome.
let's end it here now. I know people have other meetings to go to. Thank
Yep.
you so much.
Hey, thanks everybody. It was great. We're getting there. This is really good.
All right.
Thanks.
Have a
Bye.
good day.
Okay. See ya.
Thanks.